Hello there, and welcome to the Sleepy Space Channel. Here is a sobering truth about the night sky. The nearest star beyond our own sun is a place that no human being will ever reach, not with the fastest machine we have ever built, and not with any ship we know how to imagine. It lies just over 4 light-years away, a small red star called Proxima Centauri. And tonight, we are going to look closely at why that distance is far worse than it sounds. We will measure it against our fastest probes, against the speed of light itself, and against the length of a single human life. And we will find, gently, why that door is currently closed, and if it can ever be opened. If you find these slow journeys through the universe worth your time, a like or a subscribe helps the channel reach others who do. Thank you for being here. But for the next couple of hours, none of this is yours to carry. There is nothing out there you need to reach tonight, and nothing you need to do. Let your shoulders soften. Let your breathing slow. Let the distance become a far and harmless thing, drifting somewhere behind your eyes, while the day fades quietly away. Let's begin. There is a single number at the center of everything we will consider tonight, and it is a number the human mind was never built to hold. It is the distance to the nearest star, beyond our own sun. Ask almost anyone to picture that distance, and they reach for the largest thing they know, the width of an ocean, the span of the whole Earth, perhaps the gap out to the moon, and they set the star somewhere just past it. This is the first quiet mistake, and it is an honest one. The nearest star is not a little farther than those things. It is farther by a margin so wide that the comparison stops meaning anything at all. The strange part is not the size of the number by itself. The strange part is what happens as you look at it more closely. Each time you feel you have finally taken hold of how far the nearest star is, the true distance turns out to be worse than the figure you were holding. It is not worse by a little. It is worse by some new factor you had not yet counted. The road is longer than it first appears. The space along that road is emptier than it appears. The fastest machine our species has ever built is slower against it than it appears. And beneath all of it sits one unmoving speed limit, a flaw that no cleverness can dig beneath. This is what it means to say the distance is worse than you think. It does not arrive all at once. It deepens the longer you stand and consider it. Tonight, we are going to walk that distance slowly, 1 yardstick at a time, and there is nothing in it to be troubled by. We begin with the distances we almost understand, the reach to the moon, the width of a single orbit, the size of our own family of planets. We will use each of those as a measuring stick for the next. Step by step, the scale opens outward, and somewhere along the way, the ordinary words for distance fall away, because they were made for a smaller world. What is left is something quieter and stranger. It is a true sense of how the universe arranges its stars and how much room it leaves between them. The nearest star carries a name that suits it. It is called Proxima Centauri, and the first word simply means nearest. It is a small, cool red star, far too faint to see with the unaided eye, and it lies a little more than 4 light-years away. That phrase, 4 light-years, sounds almost modest. By the end of tonight, it will not sound modest at all. It will sound like one of the largest distances a person can be asked to imagine. And Proxima is the closest star of its kind, the easiest possible journey, the shortest possible crossing, the very first step into a sea that has no near shore. The reason the distance is so hard to feel is not a failure of intelligence. It is a feature of how we were made. Human judgment of distance was shaped by a world of walking and throwing and seeing across a valley. The mind handles a few steps, a few miles, perhaps the curve of a coastline. Beyond that, every large distance gets filed onto the same shelf, a shelf labeled simply far away. The moon goes there. The far side of the earth goes there. And the nearest star gets set there too, beside them, as though they were neighbors. They are not neighbors. They are not even the same kind of thing. One of them is a short walk by comparison, and one of them is a gulf that no living person will ever cross. So the work of tonight is partly a work of taking those distances off the single shelf and setting them in their true order. We will let the small distances stay small, and we will let the large ones grow to their honest size, even when that size becomes difficult to picture. The difficulty is the point. If at some moment the scale seems to slip out of your grasp, that is not confusion. That is the first accurate feeling you have had about it. The mind reaching its edge, and the universe continuing on past that edge, calm and indifferent and much larger than the reach of the hand. There is no alarm in any of this. The distance to the nearest star has been exactly what it is for longer than there have been eyes to measure it, and it will remain so long after tonight is forgotten. We are simply going to look at it directly, the way you might look at something enormous and still, and let it be as large as it truly is. The stars are not going anywhere. Neither are we. And between us and the nearest of them lies a distance worth understanding slowly, in the dark, with nothing to do but follow it outward and let it teach you the real shape of the sky. To measure something enormous, you have to start with something you can hold. So before we reach for the stars, we will build a ruler out of the distances closest to home, beginning with the only other world that human beings have ever touched. The moon is the natural first mark on the ruler, because it is the farthest any person has ever traveled, and because almost everyone has stood beneath it and felt that it was near. The moon orbits the Earth at an average distance of about 384,000 kilometers, which is roughly 239,000 miles. That is already a number too large to feel. You could line up every planet in the solar system, side by side, in the space between the Earth and the moon, and they would fit with room to spare. It is a great distance by any human measure. And yet, in the scale of tonight, it is the smallest step we will take the first short pace out the door. Light helps us feel it. Light is the fastest thing there is, and we will lean on it again and again tonight as our truest measuring stick. A beam of light crosses the gap from the Earth to the moon in a little over 1 second. If you could shine a lamp at the moon and have it answer back, the round trip of the light, the moon, in other words, is about 1¼ light seconds away. Hold that unit in mind, the light second, because we are going to watch it grow into the light minute, and then the light hour, and at last the light year, and each step will be a leap, not a stride. The next mark on the ruler is the sun, and here the distance jumps in a way that already strains the imagination. The Earth orbits the sun at an average distance of about 150 million kilometers, or roughly 93 million miles. Astronomers use this distance so often that they have made it a unit of its own. They call it the astronomical unit. 1 astronomical unit, the span from the Earth to the Sun. Nearly everything in the solar system is measured in these units, and so they will become our second yardstick, longer than the light second, and far longer than the reach to the moon. Light measures this distance for us as well. Sunlight, leaving the surface of the sun and crossing all those millions of kilometers, takes about 8 minutes and 20 seconds to reach your eyes. This has a quiet consequence worth sitting with. you never see the sun as it is. You only ever see the sun as it was 8 minutes ago. If the sun were somehow to change in this moment, the news of that change would still be on its way to us, crossing the gap at the speed of light, and would not arrive for another 8 minutes. Already, at the scale of our own star, the universe has begun to show us its past instead of its present. Think for a moment about how far one astronomical unit really is, in human terms. A passenger jet, flying without ever stopping to land, would need around 20 years to cover the distance from the Earth to the Sun. A car at highway speed would need well over 100 years, more than a single human life, simply to drive from here to our own star. And the Sun is the near thing. The Sun is the warm, familiar anchor at the center of everything we know. It is the body whose light we have felt on our skin every day we have been alive, and it is already so far away that no ordinary journey could reach it within a lifetime. This is the lesson of the first yardstick, and it is worth letting it settle before we go on. The distances inside our own solar system already exceed what a human being could ever cross by any ordinary means. The Moon is a little over 1 light second away, and it took the boldest journeys in our history to reach it. The Sun is 8 light minutes away, and nothing we have ever built carrying a person has gone even a fraction of that distance toward it. We have barely begun to cross our own small corner of space. And the nearest star, when we finally reach it tonight, will be measured not in light seconds and not in light minutes, but in years of light. The ruler we have just built, the astronomical unit, the span to our own sun, we will need more than 250,000 of them to reach the door of the very nearest star. Even the gaps between the planets already outrun the imagination long before we set out for the stars. When our neighbor world Mars comes closest to the Earth, it still lies tens of millions of kilometers away, many hundreds of times farther than the Moon. At its most distant, on the far side of the Sun, it is farther still. The planets are never truly near one another in any human sense. They are separated by gulfs that even our fastest crewed ships would take many months to cross. And these are our neighbors, the worlds we call close, all of them gathered around the same small fire. If the distances between the planets already ask for months and years, then the distance between the stars, which dwarfs them entirely, was always going to ask for something no single person could give. Before we leave the solar system behind, it is worth walking out to its edge, because even our own small corner of the galaxy is far larger than most people picture, and crossing it is the easy part of the night. If the distance to the nearest star is the ocean, then the solar system is the harbor, and even the harbor takes our fastest ships decades to clear. Begin with the planets. The Earth orbits at 1 astronomical unit from the Sun, but the family of planets reaches far beyond us. Jupiter, the largest, orbits at about 5 astronomical units, 5 times farther from the Sun than we are. Saturn lies near 10. Out past them, the 2 great ice giants drift in the cold and the dark, until you reach Neptune, the outermost of the major planets, orbiting at about 30 astronomical units from the Sun. 30 times the distance we just called too far for any ordinary journey to cross. Sunlight, which reached the Earth in 8 minutes, takes more than 4 hours to reach Neptune. A message sent from the Sun to its farthest planet, traveling at the speed of light, would spend an afternoon in transit before it arrived. Our spacecraft have made this crossing, but only slowly, and only a few of them. A small number of probes, launched decades ago and still moving outward, have passed beyond all the planets and continue into the dark. They are the farthest human-made objects in existence. They have been flying for the better part of 50 years. And in all that time, traveling among the fastest objects we have ever launched away from the Sun, they have covered only a small fraction of 1 light year. The edge of the solar system is not a wall they have struck. It is a slow thinning of the Sun's influence, a fading of the solar wind and the warmth, until the space around the spacecraft belongs more to the galaxy than to the Sun. And even past the planets, the Sun's domain continues. Far beyond Neptune, far beyond the small icy worlds that orbit out there in the cold, astronomers believe there is a great shell of frozen bodies surrounding the entire solar system, a wide, faint cloud of comets loosely held by the Sun's gravity, reaching outward to perhaps tens of thousands of astronomical units. This outer shell may extend a meaningful fraction of the way to the nearest star. The solar system, in other words, does not end at a sharp border. It simply trails off into the distance, growing emptier and colder, until at some unmarked point, the nearest star's faint pull begins to matter as much as our own Sun's. This is the first hint of the scale that is coming. The solar system is wide enough that its outer edge is already part way to the next star, and the solar system is the part we have actually crossed. Our probes have left the planets behind. They have entered the thin space between the Sun's wind and the galaxy beyond. And they will drift for tens of thousands of years more before they pass anywhere near another star, not because they are aimed at one, but simply because that is how long the emptiness takes to cross at the speeds we can reach. Let the proportions of this settle quietly. Everything we have ever done in space, every world we have visited, every probe we have launched, every photograph sent home from another planet, has happened inside this one small system, this single harbor around a single star. The whole history of human spaceflight fits inside a region that light can cross in a matter of hours. And the journey we are really talking about tonight, the journey to the nearest star, is measured not in light hours, but in years of light. We have not yet left the harbor. We have only rowed out far enough to see how wide the harbor is. The sea begins past its mouth, and the sea is what the rest of the night is about. So we carry 3 rulers with us now as we step beyond the solar system. We have the light second, which measured the moon. We have the light minute, which measured the sun. We have the light hour, which measured the outer planets. Each one was a leap beyond the last. And now we reach for the ruler that measures the stars themselves, a ruler so much longer than these that it makes them look like nothing. The distance, that light, the fastest thing in the universe, travels not in a second or an hour, but across an entire year. There is a true border out there, though it is nothing like a wall. The sun blows a great bubble in the gas of the galaxy, a region carved out by the steady wind of particles streaming off its surface. Far past the planets, that wind finally grows too weak to push back the thin gas between the stars, and there the bubble ends. A small number of our probes have crossed that boundary, passing out of the sun's own bubble and into the gas of interstellar space for the first time. It is the closest thing the solar system has to an edge. And crossing it changed nothing about the loneliness ahead, because even past that border, the nearest star remained exactly as far as before years of light away, with the whole emptiness still to cross. To cross from the scale of the solar system to the scale of the stars, we need a longer ruler than any we have used so far, because astronomical units become clumsy. Out here, the nearest star is more than 250,000 of them away. The ruler astronomers reach for is the light year, and it is worth slowing down to understand exactly what it is, because the name fools people. It sounds like a measure of time. It is not. It is a measure of distance, and it is the most honest measure of distance the universe offers. A light year is simply the distance that light travels in 1 year. To feel how far that is, you first have to feel how fast light moves, and the speed of light is already past the edge of imagination. Light travels at about 300,000 kilometers every second, which is roughly 186,000 miles every second. Not every hour, every second. In the single second it takes to say the word, a beam of light could circle the entire Earth about 7.5 times. There is nothing in ordinary experience to compare this to. It is the fastest anything can move, and as far as physics can tell, nothing made of matter and no signal of any kind will ever exceed it. Now let that speed run for a full year. In 1 year, light covers a distance of about 9.5 trillion kilometers, which is close to 6 trillion miles. That single distance what light crosses in 1 year is 1 light year. It is the ruler we will use from here to the end of the night. And the first thing to understand about it is how strange it is that we need it at all. Light is so fast that it crosses the solar system in hours. For light to take a whole year to travel somewhere, that somewhere has to be almost unthinkably far. And the nearest star is more than 4 such years away. There is a quiet beauty hidden in this ruler, and it is worth pausing on before the distances grow heavy. Because light takes time to travel, everything you see in the night sky is a picture from the past. When you look at the nearest star, you see light that left it more than 4 years ago. When you look at a star farther out, you may be seeing light that began its journey before you were born. The familiar patterns overhead are not a photograph of the universe as it is tonight. They are a slow gathering of old light, each point arriving from its own moment in the past, all of it reaching your eye at once. The sky is not a window onto the present. It is an archive, and the farther you look into it, the deeper into time you see. This is also why the light year ties distance and time together so tightly that you cannot fully separate them out here. To say a star is 4 light years away is to say 2 things at once. It is to say how far the star is, and it is to say how old its light is when it reaches you. The distance and the delay are the same fact, written in the same unit. And this will matter enormously when we begin to imagine traveling such distances, because if even light, the fastest thing there is, needs years to make the crossing, then anything slower than light, which is everything we could ever build, will need far longer. Hold the light year now beside the rulers we carried out of the solar system. The moon was about 1 light second away. The sun was about 8 light minutes away. The far edge of the planets was a few light hours away. And the nearest star is more than 4 light years away. Watch what happens to the units as we climb. Seconds became minutes. Minutes became hours. And now hours become years, a jump of thousands upon thousands, all at once. The ladder did not rise gently. It leapt, and it leapt again, and the distance to the nearest star sits at the top of leaps so large that the bottom rungs vanish from sight. That is the light year. It is the distance light crosses in a year, the truest ruler we have for the space between stars. And it is about to show us something that no one's intuition is prepared for. We are going to measure the gap to the nearest star with it. We are going to find that the gap is more than 4 of these enormous lengths. And then, slowly, we are going to discover that even 4 light years, measured with the longest honest ruler there is only the beginning of why the distance is worse than you think. It is worth dwelling on the strangeness of needing such a unit at all. Light is so fast that it could cross an entire country in the time it takes to blink, so fast that it laps the whole Earth 7 times while you say a single word. Nothing in our experience even approaches it. And yet this same impossibly fast light, turned loose toward the nearest star, must travel for more than 4 years without rest before it arrives. Take the fastest thing that exists, the thing that crosses our whole solar system in a matter of hours, and set it running toward Proxima, and it will not reach the star until 4 winters have passed. That is the gap between our fastest measure and the distance we are measuring. The ruler is almost beyond belief, and the distance makes the ruler look small. Of all the hundreds of billions of stars that fill our galaxy, exactly one is closer to us than any other, and it is the star we have been walking toward all night. Its name is Proxima Centauri, and it has been waiting at the end of our growing ruler since the first sentence. It is the nearest possible destination, the gentlest imaginable interstellar journey, and so it is the perfect place to learn what these distances truly mean. If the nearest star is out of reach, then everything beyond it is more so. Proxima Centauri lies about 4¼ light-years from the Sun. Let us put that into the units we have built. In kilometers, the distance is roughly 40 trillion of 4, followed by 13 zeros. In miles, it is about 25 trillion. And measured in astronomical units, in spans from the Earth to the Sun, it is about 268,000 of them. Remember that a single astronomical unit was already too far for any ordinary journey to cross in a lifetime. The nearest star is more than 250,000 of those lengths away, laid end to end into the dark. The star itself is small and quiet. Proxima is a red dwarf, the most common kind of star in the galaxy, and one of the least dramatic. It holds only about 1/8 of the mass of our Sun, and it shines with a tiny fraction of the Sun's light, glowing a dim red rather than brilliant white. It is so faint that, despite being the very nearest star to us, you cannot see it with the unaided eye at all. You would need a telescope to find it. The closest star in all the heavens is invisible to us on any ordinary night, lost in the dark between the brighter, more distant lights we can see. Red dwarfs like Proxima have a slow and patient nature. Because they burn their fuel so gradually, they last almost beyond comprehension, shining steadily not for billions of years, as our Sun will, but for trillions. Proxima is a small, careful flame that will outlast nearly every brighter star in the sky. It does have its restless moments. Now and then, it sends out a flare, a sudden brightening that flings energy outward into the space around it. But for the most part, it simply glows, low and red and constant, as it has for ages and will for ages more. Proxima does not travel through the galaxy alone. It is the outermost member of a small family of 3 stars, bound together by gravity. The other 2 are a closely matched pair. One a yellow star, much like our own Sun, the other a slightly smaller orange star, and they orbit each other nearby, a little farther from us than Proxima is, at about 4⅓ light-years. Proxima itself circles that central pair at a tremendous distance, far out on the edge of their gravity, taking on the order of 500,000 years to complete a single, slow loop around them. It is a faint, red outrider, drifting at the frontier of its own star system, and at this moment, in the long turning of the galaxy, it happens to be the one held closest to us. That phrase "at this moment" is worth pausing on, because even the title of nearest star is not permanent. The stars are all in motion, drifting on their own paths around the center of the galaxy, and over very long spans of time, they slowly change their arrangement. Proxima is the closest star now, and will be for a long while yet. But across hundreds of thousands of years, the stars rearrange, and the honor of nearest neighbor passes quietly from one to another. Even the closeness we are measuring tonight is a slow and temporary thing, a particular alignment in a sky that is always gently rearranging itself. So this is the destination, and this is what makes it the perfect one to study. Proxima Centauri is not a special star. It is small, dim, common, and quiet. Its only distinction is that it is the closest, the single nearest point of light beyond our own sun, the first stop on any road that leads out of the solar system. Everything we say tonight about the difficulty of reaching it is the most optimistic version of the story. Every other star is farther. Every other journey is longer. We have chosen the nearest possible shore, and we are about to find that even this shore lies across a sea that cannot, in any human sense, be crossed. A distance only matters because there is something at the far end of it worth wanting, and the nearest star turns out to have exactly that a reason to go, sitting just past the one barrier we cannot pass. Tonight, the destination is not really the point. The gap is the point. But to feel the gap honestly, you first have to feel the pull, and so we pause briefly on what waits around Proxima Centauri. Circling that small red star, astronomers have found at least one world, and it is not a giant of gas and storm, but a world roughly the size of our own. It orbits in what is called the habitable zone, the narrow band around a star, where the temperature might allow liquid water to rest on a planet's surface, neither boiling away nor freezing solid. Around a small, cool star like Proxima, that gentle band lies very close in, far nearer to the star than the Earth is to the Sun. And there, in that close, warm ring, turns a world of about the mass of the Earth. Think about what that means for a moment, quietly. The very nearest star to our own, the first one we would ever reach, the closest light in the sky, carries an Earth-sized world in the one zone where water could exist. Of all the places the galaxy could have put such a world, it placed one at our doorstep, on the closest star there is. It is the kind of coincidence that turns an abstract number into an ache. The distance to Proxima stopped being a curiosity the day we learned that something like a second Earth might be turning around it. We must be honest, though, about how little we know of that world and about the ways it is unlike home. Because it orbits so close to its star, it very likely keeps one face turned permanently toward Proxima, the way the moon keeps one face toward the Earth. On such a world, there would be no sunrise and no sunset. One side would lie in endless day, lit always by the dim red star hanging motionless in the sky. The other side would lie in endless night, in a cold that never lifted. Only along the ring between them, the slim border of perpetual dusk, might conditions be gentle. And the star's flares, those sudden outbursts of energy, may over long ages strip away whatever air such a world began with. We do not know whether it is a living place or a barren one. We only know that it is there, and that it is the nearest world of its size in all the sky. There may be more than one. Astronomers have found signs of at least one other world in the Proxima system, larger and farther out, on a wider, colder orbit, and hints of a third, smaller one, closer in. The nearest star, it seems, holds a small family of planets of its own, the way our sun does. It is not a barren point of light. It is a system, a place, with worlds, with a habitable zone, with at least one planet where the most precious thing in the universe, liquid water, might lie on the surface, beneath a red and silent sky. And all of it sits about 4¼ light-years away. That is the cruelty hidden in the wonder, and it is the true subject of tonight. The thing we would most want to reach, a possible second Earth, the nearest one there, could be lies just past the one distance we have no way to cross. The desire and the impossibility arrive together. in the same breath, attached to the same small red star. For the rest of the night, we are going to live in the space between them, between how badly a person might want to go and how completely the distance forbids it. We have felt the pull now. From here on, we measure the wall. The trouble with a number like 40 trillion kilometers is that the mind simply slides off it. We cannot picture a trillion of anything, and so the figure, however true, stays cold and far away. The way to make a distance felt is not to enlarge it, but to shrink it, to take the whole arrangement of stars and reduce it evenly until the sizes become things we can hold in the hand. Then we look at how far apart they still are. This is where the distance to the nearest star finally stops being a statistic and becomes something close to a feeling. Begin with the gentlest model. Imagine shrinking the distance from the Earth to the Sun down to the length of a single inch. The whole span that sunlight takes 8 minutes to cross now fits between 2 fingers. On that scale, the entire Earth is far too small to see, a speck finer than dust, and the Sun itself is a grain smaller than a grain of salt. Now, on that same scale, where is the nearest star? It is not across the room. It is not down the street. On the scale where the Earth and the Sun are 1 inch apart, Proxima Centauri lies more than 4 miles away. A grain of salt here, and the next grain of salt more than 4 miles off, with nothing in between but empty air. Sit with that, because it is one of the truest pictures of the night there is. Shrink our whole relationship with the Sun, the source of all our warmth, the body so far that a car would drive a century to reach it down to the width of a thumbnail, and the nearest star is still a journey across a whole town. The thing that defeats the imagination is not the size of the stars. The stars, in this model, are nearly invisible specks. The thing that defeats the imagination is the emptiness the model leaves between them. Almost all of it is nothing. The grains are vanishingly rare, and the space is almost entirely bare. Try a second model, a little larger, to feel it from another side. Shrink the Sun down to the size of a basketball, something you could hold against your chest. On that scale, the Earth becomes a small grain about the size of a peppercorn, turning in a circle some 26 meters away, across a wide room or a quiet parking lot. All the warmth and weather and history of our entire world reduced to a peppercorn 26 meters from a basketball. And the nearest star, on that same scale? Another ball, much like the first, sitting about 7,000 kilometers away. A basketball in one city, and the next basketball on the far side of an ocean, on another continent entirely, with almost perfectly empty space the whole way between. There is a third way to hold it, larger still. Shrink the entire planetary solar system, everything, out to the orbit of the farthest planet, down to the size of a small coin you could rest on a fingertip. On that scale, the nearest star is still most of a city block away, and the galaxy of hundreds of billions of stars becomes the size of a continent. The coin that holds all our planets, all our probes, all of human history in space, and the next coin like it lies a long walk down the road, and the whole spangled wheel of the galaxy stretches from one coastline to another. Notice that all 3 models tell the same story, no matter where you start. Whether the Sun is a grain of salt or a basketball, whether the solar system is an inch or a coin, the proportion never softens. The stars come out as rare, tiny specks separated by oceans of nothing, and the nearest of those specks is much, much farther proportionally than nearly anyone guesses before they do the arithmetic. The models are not exaggerations meant to frighten. They are the honest shape of things, reduced to a size the hand can check. And here is the quiet turn hidden inside the shrinking. When you make the universe small enough to hold, what you are left holding is mostly emptiness, with a few small lights set impossibly far apart. That emptiness is not a flaw in the picture. It is the picture. The space between the stars is the main feature of the galaxy, and the stars themselves are the rare exceptions scattered through it. We live on a peppercorn near one of those lonely specks, and the next specks are so far that the gap is the only honest subject. We have shrunk the sun to a ball we could carry, and the nearest other ball is a world away. That is the scale. That is what we are really standing inside every night we look up. The next part is about what fills the space between those distant balls, and the answer, almost unbelievably, is even less than you would think. We have measured the distance to the nearest star, and we have shrunk it down until we could feel it. Now we turn to the space inside that distance, the 4 light-year gap itself, and ask what fills it. The answer is one of the strangest and most peaceful facts in all of astronomy. The space between the stars is not a thick and crowded medium. It is the emptiest emptiness that exists, emptier than any nothing a person has ever stood inside, and the journey to Proxima would be a journey through almost perfect vacancy. People imagine the space between stars as a dark and busy place, full of drifting material. The truth is nearly the opposite. The gas that lies between the stars in our part of the galaxy is spread so thinly that on average there is only about 1 atom in every cubic centimeter of space, about 1 atom in a volume the size of a sugar cube. And in the particular region the sun is drifting through now, a quiet pocket swept cleaner than most, there are even fewer than that. To call it a vacuum is almost too generous a word. It is emptier than the finest vacuum our laboratories can create, with great effort here on Earth. The space a starship would cross on the way to Proxima is, for all practical purposes, nothing at all. The stars themselves take up almost none of the room. If you were to choose a point at random anywhere in the galaxy and ask whether it lay inside a star or even near one, the answer would almost always be no. The galaxy is not a crowd of suns pressed together. It is a great, slow emptiness, with stars scattered through it like a handful of sand thrown across a space too large for the throw to matter. The lights are real and they are bright, but they are exceptions. The rule, nearly everywhere you could stand, is dark and empty space. Consider how thinly the stars are spread near us. In the sun's neighborhood, stars are separated, on average, by several light-years distances, even greater than the gap to Proxima. Our sun sits in a quiet, unhurried suburb of the galaxy, not in any crowded core. If you drew a sphere around the sun reaching out 16 light-years in every direction, a sphere that sounds enormous, 4 times the distance to the nearest star, you would find only around 60 stars inside it. 60 lights, most of them dim red dwarfs, no human eye could ever see, scattered through a volume so large that light itself needs 16 years to cross it. That is how empty our corner of the galaxy is. A few dozen embers, set far apart in an enormous dark. Even in the center of the galaxy, where the stars crowd together far more closely than they do out here, they never actually touch. They never collide in the ordinary sense, never jostle shoulder to shoulder. Even in that crowded core, the distances between neighboring stars remain far greater than the sizes of the stars themselves. There is no place in the entire galaxy where the stars are packed tightly enough to brush against one another. The emptiness is not a feature of our quiet neighborhood alone. It is the condition everywhere. Space is mostly, overwhelmingly, almost perfectly empty, and the stars are the rare bright punctuation in a sentence made almost entirely of silence. It would be easy to make this sound lonely, but it does not have to be felt that way. there is a profound stillness in it instead. The space between the stars is the quietest place there is, colder than anything you could touch, emptier than any room, more silent than any silence on Earth. A traveler crossing it would pass through years of undisturbed dark, with the stars hanging motionless and patient on every side, neither approaching nor receding for a very long time. It is not a hostile emptiness. It is simply a still one, an emptiness so complete that it has a kind of peace in it, the peace of a place where nothing happens and nothing needs to. And this stillness is part of why the distance is worse than you think. It is not only that the nearest star is far. It is that the space between here and there is almost entirely nothing, no resting place, no halfway harbor, no island in the middle of the sea. To go to Proxima is not to cross a busy region dotted with stops. It is to cross 4 light-years of near-perfect vacancy, with the nearest help unimaginably far behind, and the destination unimaginably far ahead, alone in the most complete emptiness that the universe contains. The gap is not merely long. It is empty all the way across, and that emptiness is the next layer of the wall. What little does drift in that emptiness becomes strange to think about at high speed. Here and there in the gap floats a stray atom, and far more rarely, a single grain of dust, finer than smoke. At the gentle pace of our present probes, these specks mean nothing at all. But to a ship moving at 1/5 of the speed of light, even a single grain of dust would arrive with the force of something far heavier, and a whole journey's worth of such specks would wear at the vessel the entire way. So the emptiness is both a mercy and a warning. It is the only reason fast travel can be imagined at all, for a crowded space could not be crossed at speed. And it is still not perfectly empty, so that even in the stillest nothing there is, the few scattered motes would matter to anything moving fast enough to hope to cross it. So far we have only measured the distance and the emptiness. We have not yet tried to cross them. It is time to ask the natural human question, how fast can we actually go, and to set the real speeds of our finest machines against the real distance to the nearest star. This is the moment where the scale stops being a picture and becomes a sentence with a number in it that is hard to forget afterward. To do it honestly, we first have to know how fast our fastest things truly are. Begin with the fastest a human being has ever traveled. When astronauts journeyed to the moon, their spacecraft reached a speed of around 40,000 kilometers per hour, about 11 kilometers every second. That was fast enough to cross from the Earth to the moon, that 230,000-mile gap, in roughly 3 days. It remains the fastest that any crew of living people has ever flown. Hold that number gently in mind, 11 kilometers per second, the top speed of human travel, a speed at which the moon is 3 days away. Now, leave the cruise behind and look at our fastest uncrewed probes, the small patient machines we have sent into the outer solar system and beyond. The fastest of our long-range probes move away from the Sun at around 17 kilometers per second, somewhat faster than the moon-bound astronauts, because they carry no fragile passengers and have been flung outward by the gravity of the giant planets along the way. 17 kilometers per second is a remarkable speed. In a single second, such a probe crosses 17 kilometers. In an hour, more than 60,000. These are among the fastest objects our species has ever launched into the dark, and they have been traveling for decades. There is one machine that has gone faster than all the others, and it is worth describing because it represents the very limit of the speeds we have ever reached. To study the Sun, we built a small probe designed to dive in close to it, again and again, swinging around the Sun at the bottom of its plunge. And there, whipped forward by the enormous gravity of the sun itself, that probe reached a speed of nearly 200 kilometers per second, close to 700,000 kilometers per hour. Nothing built by human hands has ever moved faster than that small craft at the bottom of its dive. It is the speed record for our entire civilization, the fastest we have ever made anything go. Let us gather these speeds together before we measure them against the stars. The fastest crewed flight reached about 11 kilometers per second. The fastest long-range probes travel at around 17. And the single fastest object we have ever built touched nearly 200 kilometers per second, and only for a moment, at the bottom of a dive toward the sun. These are the peaks of everything we have achieved in motion, the absolute fastest our species has managed in all its history of building and launching and reaching outward. They are astonishing speeds by every human measure. A rifle bullet is slow beside them. The fastest aircraft is slower still. And yet, when we hold these speeds up against the distance to the nearest star, something quiet and humbling happens. These triumphant numbers, these record-setting velocities, all at once look almost like standing still. The distance to Proxima is so enormous that even our fastest machine, going its absolute fastest, makes almost no impression on it. The speeds that carried us to the moon and out past the planets, the speeds we are rightly proud of, turn out to be barely a crawl against the gap between the stars. In the next part, we will do the arithmetic plainly. We will take these real speeds and this real distance and simply divide one into the other, and we will find out how long the journey to the nearest star would actually take. The answer is the center of everything tonight, and it is worse than almost anyone expects. The machines themselves deserve a moment of admiration before we set them against the dark. Each was a triumph of patience and care, the work of many hands over many years. Each crossed distances that would have seemed impossible not long before. They are the farthest reach of everything we know how to do. And that is exactly what makes the next part so sobering, because it is not our weakness we are about to measure against the stars. It is our strength. It is the very best we can do. And even our very best, as we are about to see, falls almost unimaginably short of the nearest shore. It helps to feel these speeds against ordinary things. 17 kilometers in a single second is many times faster than a rifle bullet leaves its barrel. Nearly 200 kilometers in a second, the pace of that sun-diving probe would carry it across an entire country in the space of a few heartbeats, faster than any thought could follow. These are not speeds the body could ever sense or survive in the ordinary way. They are the fastest motions our species has ever set in motion. And the quiet wonder of the night is that even these speeds that would cross nations between one breath and the next amount to a slow crawl when measured against the gap to the nearest star. Now we do the simple arithmetic that the whole night has been building toward. We have a distance about 40 trillion kilometers to the nearest star. We have speeds, the true top speeds of our finest machines. To find the travel time, we only have to divide the distance by the speed. There is no trick in it, no hidden complication. It is the same calculation you would use to find how long a car trip takes. And the answers it gives are the quiet center of why the stars are beyond us. Start with the fastest crewed flight, the speed that carried astronauts to the moon, about 11 kilometers per second. Aim a ship at Proxima and hold that speed, and the journey would take more than 100,000 years. Let that settle for a moment. At the fastest speed any human crew has ever traveled, the trip to the nearest star would last longer than our species has had cities, longer than written history many times over. A child who set out at the dawn of human civilization, traveling at the speed of the moon missions, would still not have arrived. The fastest we have ever carried people is, against this distance, 100,000 years slow. It is worse for ordinary travel. A passenger jet, the kind that crosses oceans in a day, would need around 5 million years to reach Proxima if it could somehow fly there without stopping. 5 million years far longer than there have been human beings of any kind. The distance is so great that our everyday idea of fast, the aeroplane that shrinks the whole Earth to a day's travel, becomes meaningless. The airplane would still be flying long after every trace of the world that built it had worn away. Now use our fastest uncrewed probes, the ones already drifting beyond the planets at about 17 kilometers per second. These are among the swiftest objects we have ever launched, faster than the astronauts, faster than anything carrying a crew. Aim one at Proxima, and the journey would still take more than 70,000 years. 70,000 years of flight through the empty dark for our fastest long-range machines to reach the very nearest star. The probes we have already launched will, in fact, drift for tens of thousands of years before they pass anywhere near another star at all, not because they are aimed at one, but simply because that is how long the emptiness takes to cross at the best speeds we can manage. And what of the fastest object we have ever built? That small probe diving past the sun at nearly 200 kilometers per second. Surely the speed record of our entire civilization does better. It does, and still the answer is staggering. Even at that blistering pace, the fastest velocity any human machine has ever reached, the journey to Proxima would take on the order of 6,000 or 7,000 years. Longer than all of recorded history. And this is the most generous case imaginable, because that probe only touches its top speed for a few moments at the bottom of its dive toward the sun, and it is moving in the wrong direction entirely inward, toward our star, not outward toward another. It could never hold that speed across the open gap. Even pretending it could, even granting it the best moment of its fastest dive, the nearest star is still thousands of years away. Here, then, is the sentence the whole night has been carrying toward you. Our fastest machine, going its absolute fastest, in a straight line toward the nearest star, would not arrive for thousands of years. No one alive at the launch would be alive at the arrival. Not their children. Not their children's children. Not, perhaps, the civilization that built the ship at all. The crossing is longer than nations, longer than languages, longer than the memory of why the journey began. And this is the easy case, the nearest star, the shortest possible trip, measured against the very best we can do. This is the true meaning of the title. The distance is not worse than you think, because the number is large. It is worse than you think, because the number, divided into our greatest speeds, gives an answer measured not in years and not in lifetimes, but in the rise and fall of whole civilizations. We have stood on the moon. We have sent our machines past every planet, and the nearest star, the closest other sun in all the sky, lies thousands to tens of thousands of years away at the fastest we have ever moved. The arithmetic is simple. The result is a wall. And in the parts ahead, we will see why we cannot simply build something faster to climb over it, because the wall, it turns out, goes higher than any engine can reach. Let one of those figures settle into human terms. 100,000 years, the time the fastest crewed flight would need to reach Proxima, reaches back farther than our whole settled history, farther than farms and cities and writing, back to when our ancestors had not yet spread across their own single world. Whole ice ages have come and gone in less time than that. The journey to the nearest star, made at the fastest a person has ever traveled, would be longer than the entire memory of our kind. Someone setting out at the dawn of everything we would recognize as human would still, even now, be far from arriving. The obvious answer to a journey that takes tens of thousands of years is to go faster, far faster. If our best machines are too slow, then build a better one. It is a fair thought, and it deserves a full and honest answer, because the reasons we cannot simply accelerate our way to the stars are themselves part of the wall. The barrier is not a lack of imagination. It is a stack of physical costs that grow faster than any engine can keep pace with. Begin with the way a rocket moves at all. A rocket goes forward by throwing material out behind it, burning fuel and flinging it backward, so that the ship is pushed the other way. This works beautifully, but it hides a cruel arithmetic. To go faster, a rocket must throw more fuel, or throw it harder. But the fuel has weight, and that weight must also be carried and pushed, which demands still more fuel, which adds still more weight. Each bit of speed you want costs fuel, and the fuel to carry that fuel, and the fuel to carry that. The cost does not add gently. It multiplies, and it multiplies steeply. The result is that to reach even a small fraction of the speed of light by ordinary rocketry, the amount of fuel required swells beyond all reason. It quickly passes the mass of the entire ship, then the mass of everything humans have ever built, and then climbs into quantities that have no relationship to anything we could gather or carry. Chemical rockets, the kind that lift us off the ground, the only kind we have ever used to leave the Earth, simply cannot reach the stars. It is not that we have not built a large enough one. It is that no rocket of that kind, of any size at all, could carry the fuel its own speed would require. The arithmetic forbids it before the engineering even begins. Then there is the matter of energy, and here the wall rises from a different direction. The energy needed to reach a given speed does not grow in step with the speed. It grows with the square of the speed. Double how fast you want to go, and you need 4 times the energy. Increase it tenfold, and you need 100 times. To push even a modest ship to a meaningful fraction of the speed of light would demand an amount of energy comparable to the entire output of human civilization. Every power plant, every furnace, everything we generate, gathered together and poured into a single vessel. And that is only to reach the speed. To slow down again at the far end, to actually stop at the destination rather than flying past it, you must pay a similar price all over again. There are gentler engines we can imagine, and honesty requires naming them. We can picture ships driven by the energy locked inside the atom, far more potent than any chemical fire. We can picture great thin sails pushed by sunlight, or by powerful beams of light fired from home. These ideas are real, and some of them could, in principle, do far better than chemical rockets ever could. But each carries its own steep difficulties, and not one of them, as far as we can presently see, lifts the journey out of the realm of centuries and millennia for anything large enough to carry a human being. They soften the wall. They do not open a door in it. The honest summary is this: the gap between what we can do and what we would need to do is not a small gap, the kind a clever new idea might close in a generation. It is a gap of many factors of 10, each stacked upon the last. The fuel problem, the energy problem, the slowing down problem, and the size of every one of them is set by the same enormous distance we have been measuring all night. The distance does not only make the journey long, it makes the journey expensive in a way that grows steeper the faster you try to go, so that speed itself becomes a kind of trap. The faster you wish to travel, the more impossibly the costs rise. And even if we imagine all of these problems solved, even if we grant ourselves unlimited fuel, unlimited energy, and an engine of perfect efficiency, there remains one final barrier that no amount of cleverness can lower. It is not a limit of our machines or our resources. It is a limit built into the structure of the universe itself, a ceiling above all the others. It is the speed of light, and it is the subject of the next part. For there is a fastest possible speed that anything can travel, and the nearest star is more than 4 years away, even at that ultimate pace. Suppose we set aside every practical problem. Suppose we grant ourselves all the fuel we could want, all the energy a civilization could pour out, an engine of impossible perfection, and a ship of impossible strength. Even then, one barrier remains that no cleverness can ever lower, and it is the lowest part of the whole wall. It is not a limit of engineering. It is a limit of the universe. It is the speed of light itself, and understanding it is the last and largest piece of why the stars are beyond us. We have already met the speed of light as the fastest thing there is, 300,000 kilometers every second, the pace at which sunlight crosses to us in 8 minutes, and a star's light reaches us across years. But it is more than merely the fastest thing we have observed. As far as all of physics can tell, it is the fastest that anything can ever be. It is a true ceiling, a hard edge woven into the fabric of space and time, and nothing made of matter is permitted to reach it, let alone pass it. The reason is strange and worth holding gently. As an object that carries mass is pushed faster and faster, the energy needed to speed it up further does not stay steady. It grows. And as the object's speed creeps closer and closer to the speed of light, the energy required to gain even a little more speed grows without any limit at all. To actually reach the speed of light, a ship with any mass whatsoever would need an infinite amount of energy, which is simply to say that it can never be done. The closer you press toward that ceiling, the more it costs to press further, until the cost becomes more than the whole universe could supply. The speed of light is not a finish line that a better engine could cross. It is an edge that everything with mass is forbidden to touch. This changes the nature of the wall entirely. Until now, every barrier we met was, in principle, a matter of degree, a question of more fuel, more energy, more patience. But the speed of light is different. It is not a barrier we are too weak to climb. It is a barrier that cannot be climbed by anything made of matter, no matter how strong or how clever, because the laws of the universe themselves forbid it. Our ships will always be slower than light. Not a little slower in the cases that matter, but meaningfully slower, because reaching even close to light's speed demands those unimaginable energies. And the nearest star is more than 4 light-years away. Here is what that means, laid plainly. There is a flaw beneath the travel time to Proxima that nothing can ever dig below. Even a pulse of light, the fastest thing the universe allows, needs more than 4 years to make the crossing. So no message, no ship, no signal of any kind can ever reach the nearest star in less than 4 years, and anything we could actually build, being slower than light, would take longer still. For a beam of light, more than 4 years. For a fast probe, tens of thousands. For a crude ship by any means we can describe, longer than civilizations last. The speed of light sets the gentlest possible limit, and even that gentlest limit is measured in years. And yet there is something in this final barrier that turns, quietly, toward peace, and it is worth carrying with you. The same speed of light that keeps us from the stars is also what holds the night sky still. Because light takes years to cross between the stars, and because nothing moves faster, the stars cannot rush at us or scatter away. They hold their places, steady and patient, through a human life and 100 human lives. The constellations your distant ancestors saw are very nearly the constellations you see tonight. The fixedness of the sky, its calm reliability, the way the same stars return season after season, all of it rests on the very limit that keeps them out of reach. The ceiling that walls us in is the same fact that keeps the heavens constant. The distance that we cannot cross is the distance that keeps the stars from ever being lost. There is a way of seeing this limit that makes it feel less like a barrier and more like a property of the world itself. The speed of light is not really about light alone. It is the fastest that any cause can reach any effect, the top speed at which one thing can ever influence another anywhere in the universe. Light happens to travel at exactly that pace because light has no mass to hold it back. So the limit we keep meeting is not a quirk of beams and lamps. It is the rate at which the universe allows anything to matter to anything else. The nearest star lies more than 4 years away at that ultimate rate, which means more than 4 years separate any action here from any consequence there. The distance is not only a distance in space, it is a distance in cause and effect, woven into how the universe is allowed to work. There is one strange door in the wall, and honesty requires that we open it before we close it again. The same laws of the universe that forbid traveling faster than light also do something strangely unexpected to time itself. They bend it in a way that could, in principle, shorten a journey to the stars. It is the nearest thing to a loophole that physics offers. But like every other part of the wall, it asks for the one thing we cannot give, and so it ends not in escape, but in a quieter kind of wonder. The effect is real, and it has been measured many times in careful ways. When an object moves very fast, close to the speed of light, time aboard, it runs slowly, compared to the time of the world it left behind. This is not an illusion or a trick of the clocks. It is the actual behavior of time at high speed, woven into the structure of space and time together. The faster you move, the more steeply your own time slows relative to those you left at home. At ordinary speeds, the effect is far too small to notice. But as a ship approaches the speed of light, the slowing grows and grows until it becomes enormous. Here is what that could mean for a journey to the nearest star. A ship traveling at speeds very close to that of light could, in the experience of those aboard it, cross to Proxima, not in years, but in a handful of weeks or months. The crew would feel only a short voyage pass. They would age only a little. To them, the nearest star would seem almost near, reachable within a single season of their lives. For the travelers themselves, the enormous distance would fold down into something a human life could hold. The loophole is genuine. Time itself would bend to make the crossing brief for the ones who made it. But the gift is only ever for the traveler, and never for the world left behind, and this is where it begins to turn. While the crew felt only weeks go by, the full years would still pass back home more than 4 years for the light of their arrival to even return, and more than 8 for any round trip. A crew that experienced only a few months of travel would return, if they returned at all, to a home nearly a decade older for a single trip to the nearest star, and far older for any journey deeper into the galaxy. They would step off the ship young, into a world that had aged without them. The distance, in a sense, is paid in time rather than in years of waiting, but someone always pays it, and the universe keeps the full account. And there is the further problem, the one that quietly closes the door. To feel time slow appreciably, a ship must already be moving at nearly the speed of light. And to reach nearly the speed of light is to need exactly those impossible energies we spoke of before, quantities comparable to the output of a whole civilization, poured into a single vessel, and then paid again to slow back down. The loophole that bends time is only opened by the very speed we have no way to reach. The key to the door is the wall itself. We cannot use the shortcut, because the shortcut requires us to have already done the impossible thing. So time dilation does not rescue the journey to the stars. It does something stranger and, in its way, more beautiful. It reveals that the barrier between us and the nearest star is not a simple matter of distance and patience. It is a barrier woven into time as well as space, a wall that can bend the hours around itself, that could make the crossing feel brief to one who made it, and still does not let a human body through at any price we could ever pay. The universe leaves the door visible so that we can see clearly what lies on the other side. It simply places the key out past the edge of any intense sea we can do, and we are left to stand before it, understanding at last that the distance to the nearest star is not only long. It is woven so far into the fabric of things that even time itself cannot quite undo it. If we cannot send ourselves to the nearest star, perhaps we imagine sending something gentler, not a ship, not a body, but a message. A signal. A word across the dark. Surely a conversation, at least, could reach Proxima, even if a traveler never could. But the same distance that defeats every ship also stretches communication into something almost unrecognizable, because even at the speed of light, the gap is measured in years. This is the softest illustration of the scale, and in some ways the loneliest. A message sent toward the nearest star travels, at its very fastest, at the speed of light. We already know how slow light becomes against this distance. A signal beamed to Proxima today would take more than 4 years simply to arrive. And any reply, set out the moment the message was received, would take more than 4 years to come back. The shortest possible exchange, a single question and a single answer, would span more than 8 years between the asking and the hearing. You would send a word to the nearest star, and you would be more than 8 years older before any answer could reach you. There is no way to hurry this. It is not a matter of building a stronger transmitter or a finer antenna. The delay is set by the speed of light and the size of the gap, and neither can be changed. A real conversation, the back and forth of ordinary speech, is simply impossible across such a distance. Every message becomes a kind of letter sent into the future, to be answered, if at all, years later, by someone who has lived years of their own life in the meantime. The nearest star is close enough that we can see it and study it and dream of it. It is far too distant for us ever to simply talk with anything there. Imagine, for a moment, a traveler partway to Proxima, looking back toward home. The light of the world they left would reach them always late, always stale news from Earth that was already years old by the time it arrived, growing older with every kilometer they traveled. Every word from home would be a message from the past. Every word they sent back would be a message into a future they could not yet see, to be received long after they had sent it. The farther they went, the wider that gap in time would grow, until home was not only distant in space but distant in time, a place they could only ever hear from across years, never in the present moment. And the signals themselves grow faint with distance, which deepens the solitude further. A transmission spreads as it travels, thinning and weakening across the light years, so that by the time it crossed the gap to Proxima, it would be a whisper, requiring enormous care to gather at all. The dark between the stars does not only delay our messages, it dilutes them, scatters them, until holding a clear thread of words across 4 light years becomes a feat in itself. The emptiness we spoke of earlier is not only empty of matter, it is empty of any easy way to reach across it. This is the quietest face of the distance, and perhaps the gentlest. Even light, which crosses the whole solar system in hours, which outruns absolutely everything, is reduced by this gap to a slow and patient crawl, taking years to make the nearest crossing between stars. The fastest thing in the universe becomes slow here. The simplest act, the sending of a word, becomes a matter of years. And so, even in our imagination, even when we send nothing heavier than a beam of light, the nearest star holds itself apart from us, close enough to speak to, far too distant ever to be answered, within the span of an ordinary day, or month, or year. We may call out to it. We will simply have grown older, always, by the time it could ever call back. There is a tender way to feel this. Imagine sending a single, simple greeting toward the nearest star, only a few words, beamed into the dark. A child could speak that greeting into the transmitter, and that same child would be more than 4 years older before it even arrived, and well into adulthood before any answer could return. A message sent at the start of a life is answered, at the earliest, years into that life. The conversation outlives the moment that began it. Nothing about the gap allows for the quick back and forth that we mean by talking. Every exchange with the nearest star would be a slow correspondence across years, each word a small, patient act of faith sent into a silence that takes a long time to answer. Fairness requires that we acknowledge the single idea that comes closest to crossing the gap within a human lifetime, and then see, clearly and without disappointment, why even that idea does not carry us with it. There is one concept that has been studied seriously, one design that could in principle reach the nearest star in years rather than millennia. It is a beautiful idea, and it deserves to be described with admiration, because the way it almost works teaches us as much as the ways that fail. The idea begins by giving up on the great ship entirely. Instead of a massive vessel carrying fuel and crew, it imagines something almost weightless, a tiny probe, no larger than a chip, no heavier than a few grams, attached to a thin and shining sail. Not one of them, but a whole swarm, sent out together. Each little craft would carry almost nothing: a small camera, a tiny transmitter, a sliver of electronics, and the gossamer sail that catches the push of light. The genius of it is in the lightness. By making the traveler almost nothing at all, the design slips past the cruel arithmetic of fuel that defeats every heavier ship. For the sail carries no fuel. It is pushed from home. The plan imagines an enormous bank of lasers here in our own solar system, firing a concentrated beam of light at the little sails, pressing on them steadily as light does, accelerating them not over years but over mere minutes. In that brief push, a sail might be driven to a fifth of the speed of light, 20 times faster than anything we have ever built, fast enough to reach the nearest star not in tens of thousands of years, but in something like 20. A journey within a single human life. A signal that could come home while the people who launched it were still alive to receive it. It is the one design that brings the nearest star within the span of a lifetime, and that alone makes it remarkable. But notice everything the lightness costs, because the same featherweight that makes the journey possible also empties it of almost all it could carry. These probes would weigh only grams. They could hold a camera and a transmitter and very little else. No crew, of course, no living thing of any kind, nothing remotely like a person. And there is a sharper limit still. Having no fuel of their own, and having been flung forward at a fifth of the speed of light, the little sails could not slow down at the far end. They could not stop. They could not enter orbit, or linger, or explore. They would flash past Proxima and its worlds in a matter of hours, gathering what images and measurements they could in that brief streak through the system, and then continue on into the dark beyond, unable ever to return or even to pause. And after that hurried passage, the data would still have to come home across the same 4 light-years, at the speed of light, taking more than 4 years to arrive, growing faint along the way. So the most hopeful plan we have, the one bright idea that reaches the nearest star within a lifetime, amounts to this: a swarm of featherweight postcards, thrown so fast they cannot stop, taking 20 years to arrive, racing past their destination in a single afternoon, and sending home a few precious minutes of pictures across 4 more years of empty space. It is a way to glance at the nearest star. It is a wonderful thing to imagine. It is not, in any sense, a way to go there. This is the lesson hidden in the one idea that almost works. The only way we can presently conceive to cross the gap quickly is to make the traveler so light that it is barely a traveler at all, a few grams of instruments, unable to stop, carrying no one. The moment you ask for anything heavier, a probe that could slow down and stay, a vessel that could hold supplies, and far more than that, a ship that could carry a single living human being, the whole design collapses back into the realm of centuries and millennia, back behind the wall. We can throw a postcard at the nearest star and hope to catch its faint reply. We cannot send ourselves. The distance permits the glance and forbids the journey, and even the glance takes the better part of a lifetime to complete. Underneath all the physics, the fuel, the energy, the speed of light, the bending of time, there is a simpler barrier, the one that needs no equation at all. A human being does not live long enough. We have measured the journey to the nearest star in tens of thousands of years at our best sustained speeds, and even the most hopeful designs ask for centuries. No person could ever live to see both the beginning and the end of such a crossing. And so, if the journey is ever to be made by people at all, it could only be made the way a river is crossed by a forest slowly, by many generations, none of whom would see both shores. This is the idea of a generation ship, and it is worth picturing gently, because it is the most human part of the whole story. Such a vessel would not carry a crew in the ordinary sense. It would carry a small society people who would live their whole lives aboard, have children aboard, grow old and die aboard, and be buried, somehow, in the dark between the stars. Their children would be born in transit, knowing no home but the ship, and would themselves grow old and pass the voyage to their own children. Only some distant generation, far down the line, would ever arrive. The travelers who stepped aboard would not be the travelers who arrived. They would be separated by more lifetimes than separate us from the building of the first cities. Think of what such a ship would have to be. It would have to be a small, closed world, complete in itself, sealed against the emptiness. It would have to grow all its own food, recycle every breath of air and every drop of water, hold itself in repair without any harbor to return to, and never run out of anything essential across spans of time longer than recorded history. It would have to keep not only its machinery working, but its people whole, their knowledge, their purpose, their will to continue a journey, begun by ancestors they never met, toward a destination their descendants might never confirm. It is as much a problem of holding a society together as of holding a ship together, and across timescales that have undone every empire that has ever existed on Earth. And even the most optimistic, faster designs, the ones that might somehow cross in mere centuries rather than tens of thousands of years, still ask more than a single human life can give. A few centuries is far shorter than 100,000 years, but it is still many lifetimes laid end to end. The person who chose to go would not arrive. They would give their entire life to the early part of a journey whose end they would never witness, trusting that others, not yet born, would finish what they had begun. There is something noble in that thought, and something almost unbearably lonely. This is the quietest version of the whole night's truth, and perhaps the most honest. The distance to the nearest star is longer than a human life, by so wide a margin that no single person could ever experience both the leaving and the arriving. To set out for Proxima would be to accept, at the very start, that you yourself will never see it, that you are not the traveler, but only the beginning of a line of travelers, sending your distant descendants ahead into a dark you will not live to cross. The journey is not measured against your patience. It is measured against your whole existence, and it is longer. And so even setting aside every problem of fuel and energy and light speed, even granting a ship that could somehow make the crossing, the distance defeats the traveler in the most basic way of all. It outlasts them. A life is too short to hold it. The road is longer than the walker, longer than the walker's children, longer than the memory of why the walking began. That is the final, gentlest weight in the word unreachable. Not that we lack the machine, but that we lack the years, and the nearest star asks for more years than a person has to give. Picture, gently, a child born somewhere in the middle of such a voyage. That child would know no sky and no horizon, no wind and no open ground, only the curved walls of the ship, the hum of its machines, the same faces and corridors for a whole lifetime. The Earth would be a story to them, a place in old recordings, no more real than a distant legend. The destination would be an article of faith, a star they had never seen grow any nearer in any way they could feel. They would live and love and grow old entirely inside the crossing, neither at the world that launched them nor the world ahead, but somewhere in the long middle of the dark. The distance does not only outlast the traveler, it swallows whole generations who know nothing but the journey itself. Everything we have said tonight has been about the nearest star, the closest, the easiest, the most forgiving possible destination. It is worth pausing now to remember that Proxima is the near one. It is the gentlest case there is. And the moment we lift our eyes past it, to the other stars scattered across the sky, the distances only grow, and grow steeply, until the figures we have struggled with tonight begin to look small by comparison. The closely matched pair of stars that Proxima belongs to, the Sun-like star and its orange companion, lie a little farther than Proxima itself, at about 4 1/3 light-years. Beyond them, the next nearest stars stretch out to 6 light-years, and 8 and 10. Within the small sphere, we drew earlier 16 light-years across. There are only around 60 stars, and most of those are dim red dwarfs, far fainter than the ones we can see. Each of them is a journey longer than the one to Proxima. Each lies behind the same wall, only farther back. And the bright, familiar stars, the ones that actually catch the eye on a clear night, the ones that form the patterns we have named, are mostly far more distant than these faint near neighbors. Many of the stars you can pick out by eye lie tens or hundreds of light years away. Some of the brightest lie farther still. They appear close to us only because they shine so fiercely that their light carries across enormous gulfs. The stars we know best by sight are, almost all of them, much farther than the nearest star we cannot even see. To travel to one of those would make the journey to Proxima look like a single short step at the very beginning of an endless road. Then widen the view once more to the galaxy entire. Our Sun is one star among hundreds of billions, all bound together in a slowly turning wheel of light. That wheel is about 100,000 light-years across. If a journey of 4 light-years to the nearest star takes tens of thousands of years at our best speeds. Then, a journey across the galaxy, 100,000 light-years, lies so far beyond reach that the numbers stop carrying any feeling at all. We have measured the gap to the nearest star and found it a wall. The galaxy is that wall repeated tens of thousands of times over, in every direction. And the galaxy itself is only one among a great many. Beyond it lie other galaxies, each a wheel of hundreds of billions of stars, separated from ours by distances measured not in thousands of light-years, but in millions. The nearest large galaxy to our own lies more than 2 million light-years away. The light reaching us from it tonight set out before there were human beings to receive it. Against such distances, the entire span of our galaxy is a small thing, and the journey to the nearest star, our impossible 4 light-years, becomes almost too small to find on the scale at all. This is not meant to deepen the difficulty into despair. It is meant to set the nearest star in its true place. When we say that Proxima is beyond our reach, we are speaking of the very closest thing there is, the single most reachable point in the entire universe, beyond our own solar system. Everything else, every other star, every other galaxy, every other light in the sky, lies farther, often unimaginably farther. Proxima is not the hard case. It is the easy one. And if even the easy one lies across a gulf that a human life cannot cross, then the size of the universe is not a thing to be conquered. It is a thing to be witnessed, from where we stand, with the patience the distances themselves seem to teach. There is a quiet wonder folded into this, beyond the difficulty. The bright, familiar stars we steer by and name and love are so far that their light is old when it reaches us. Some of it set out centuries ago, crossing the dark all this time to arrive tonight. A few of those distant stars may already have changed, even ended, in ways whose news has not yet had time to cross the gap to us. We would go on seeing their old light for years or lifetimes, unaware. The farther sky is not only beyond our reach in space, it is beyond our reach in time as well, showing us the distant past of places we can never visit, lights that shine for us out of a depth we can measure but never cross. It is fair to ask how anyone could possibly know these distances at all. No one has traveled to the nearest star and measured the road. No tape stretches from here to Proxima. And yet astronomers speak of 4¼ light-years, with quiet confidence, as though it were a settled thing. The way they came to know it is one of the gentlest and most patient achievements in all of science, and it is worth understanding because it shows how the human mind reaches across a distance the human body never could. The method rests on a simple piece of everyday experience. Hold a finger up at arm's length and look at it with one eye, then the other. The finger seems to jump against the background behind it. Closer objects shift more, farther objects shift less. This small shift, this apparent motion of a near thing against a far backdrop when you change your viewpoint, is the key that unlocks the distance to the stars. Astronomers call it parallax, and it turns the simple act of looking from two places into a way of measuring the unreachable. The two viewpoints they use are the two opposite sides of the Earth's own orbit. As our world travels around the Sun across the year, we are carried from one side of that great circle to the other, a shift of about 300 million kilometers from one season to the season half a year away. Astronomers measure the position of a nearby star very precisely, wait half a year for the Earth to swing to the other side of its orbit, and measure again. The near star appears to shift just slightly against the far more distant stars behind it. From the size of that tiny shift and the known width of the Earth's orbit, The distance to the star can be worked out by careful geometry. The shifts are unbelievably small. Even for the nearest star, the apparent movement across the sky is so slight that it took enormous patience and precision to detect it at all. The distances are so great that even the entire width of the Earth's orbit, that 300 million kilometer baseline, produces only the faintest flicker of motion in the nearest star's position. This is itself a measure of how far away the stars are. The whole span of our planet's yearly journey, set against the distance to even the closest star, is almost nothing, just barely enough to produce a shift that the most careful instruments can catch. From this gentle method, the entire scale of the stars unfolds. By measuring these tiny seasonal shifts, astronomers found the distance to the nearest stars, and from there, step by step, built up the larger ladder of distances that reaches across the galaxy and beyond. The 4¼ light-years to Proxima is not a guess. It is the result of watching a faint red star shift by a hair's breadth against the dark twice a year, and reading the distance out of the geometry. The number we have leaned on all night was earned by patience and care, by looking very closely at very small motions and trusting the arithmetic of triangles to carry the mind where the body could never go. There is something fitting in this, on a night spent contemplating a distance we cannot cross. We cannot send ourselves to the stars, but we have found a way to measure them, to know them truly, to lay out their distances with confidence, all from here, from the surface of our small world, using nothing but careful looking and patient thought. The stars hold themselves beyond our reach. And still, without ever leaving home, we have learned exactly how far beyond our reach they are. The measuring is its own kind of journey, one the mind can make even when the body cannot. There is a quiet trick the night sky plays on us, and it lies close to the center of why the distance to the stars is so hard to believe. When we look up, the stars seem near. They seem to hang just overhead, bright and clear, as though a tall enough tower might reach them. This feeling is powerful and ancient, and it is completely mistaken. The brightness that makes the stars feel close is exactly what hides their true distance from us, and understanding the deception is part of seeing the sky honestly. The stars appear to us as points of light, with no sense of depth. The eye cannot tell how far away a glowing point is. A candle nearby and a bonfire far off can look equally bright, and the eye has no way to choose between them. So when we look at the stars, we receive only their brightness, with no built-in sense of distance attached. And brightness, it turns out, is a terrible guide to how far a star truly is, because the stars differ enormously in how much light they actually give off. Consider the nearest star, Proxima. It is the very closest star to us, and yet you cannot see it at all without a telescope. It is a small, dim red dwarf, giving off so little light that even from the front row, as it were, it remains invisible to the unaided eye. Meanwhile, some of the brightest stars in our sky are enormous, brilliant suns, lying hundreds of light years away, far, far more distant than Proxima, that appear bright to us, only because they pour out so much light that even across that great gulf, enough reaches us to catch the eye. The brightest star in the sky is not the nearest. The nearest star is one we cannot see. Brightness and nearness, which we instinctively join together, have almost nothing to do with each other. This means the night sky we see is sorted not by distance, but by a tangled mix of distance and true brightness, with no way for the eye to separate them. A modest star close by and a giant star far away can sit side by side in the same patch of sky, looking like equals, though one may be 10 times farther than the other, or 100 times. The familiar patterns overhead, are not arrangements of stars at similar distances. They are chance alignments of stars scattered through a great depth, some near, some impossibly far, all flattened by our eyes onto the same dark dome. And so the feeling that the stars are close, the sense that they hang together just above us, almost touchable, is a kindly illusion. The stars are not gathered on a ceiling. They are strewn through the depths at wildly different distances, the nearest invisible, the brightest remote, and the whole arrangement is far deeper than it appears. When you look up and feel that you could nearly reach them, what you are really seeing is the light of many suns at many distances, all reduced to the same flat sparkle, their true remoteness erased by the simple fact that light, however far it travels, still arrives as a point in the eye. There is a strange comfort in knowing this, rather than a loss. The sky becomes more wonderful, not less, when you understand that you are looking into a depth. You cannot feel that each point of light sits at its own distance, the nearer ones dim and humble, the farther ones blazing across unthinkable gulfs to reach you. The flatness is in our eyes, not in the heavens. The real sky has depth beyond depth, layer beyond layer, the nearest star and the farthest, all mixed together overhead. And to lie beneath it, knowing this, is to rest beneath something far larger and deeper than it appears. A darkness with true distance folded into it, quietly, behind every star you see. We have spoken of the stars as fixed points, steady and unmoving, and across a human life, they very nearly are. But the distance to the nearest star is bound up with another slow truth that is worth sitting with on a quiet night. The stars are not truly still. They are all in motion, drifting on their own long paths through the galaxy, and over spans of time long enough, the whole arrangement of the sky slowly changes. Even the title of nearest star is only a passing one, held for a while and then handed on. Every star we see is traveling. Our own sun moves through the galaxy, carrying us with it, and every other star moves too, each on its own course around the distant center. Because the stars are so far away, this motion is almost invisible to us. A star may be crossing space at tremendous speed, and still, seen from our great distance, it seems to creep across the sky so slowly that a human life is far too short to notice. But the motion is real, and it never stops. Given enough time, tens of thousands of years, hundreds of thousands, the stars visibly shift, and the familiar patterns slowly come apart. The nearest star takes part in this slow drift, like all the others. Proxima Centauri is not fixed beside us. It is moving, drifting along its own path, and at present it happens to be carried slightly closer to us with each passing age. For a long while yet, it will continue to draw a little nearer, reaching its closest approach to our sun in the far future, before beginning, ever so gradually, to fall away again. The 4¼ light years between us is not a permanent figure. It is the reading of this particular age, a single frame in a film that runs for hundreds of thousands of years, and it shifts, slowly, as the two stars drift along their separate ways. And because the stars all move, the honor of nearest neighbor is itself temporary. Proxima is the closest star now, and will be for a long span to come. But across the great reaches of time, as the stars rearrange, other stars will drift inward and take the title in their turn, each becoming, for an age, the nearest light beyond our sun, before yielding it again to another. The sky has had different nearest stars in the distant past, and it will have different ones in the distant future. The closeness we have measured tonight is not a fixed fact of the universe. It is a slow and shifting arrangement, a particular alignment that happens to hold during the brief age in which we live. Think of the patterns overhead in this light. The shapes our distant ancestors traced among the stars were very slightly different from ours, and the shapes our distant descendants will see will be different again, the same stars, drifted into new arrangements, the old figures gently pulled out of true. Nothing in the sky is truly permanent. It only moves so slowly, across distances so great, that within a single life it appears to stand perfectly still. The constancy of the stars is real on the scale of a human life and an illusion on the scale of the galaxy. Both things are true at once. There is a profound calm in this, rather than unease. The same enormous distances that keep the stars beyond our reach also slow their motion to a stillness we can rest beneath. The sky changes, but so gently, across spans so far beyond a human life, that for us it is steady and dependable, the most reliable thing we know. We live inside one quiet frame of an immensely slow rearrangement. And in our frame, the nearest star is Proxima, 4¼ light-years away, drifting almost imperceptibly closer in a dark that will go on shifting its stars long, long after this night, and this thought have faded into the past. We have walked a long way tonight, from the gap to the moon, out to the edge of the galaxy and back. Now, before we let the subject soften into sleep, it is worth gathering everything into one quiet place, laying all the pieces side by side, so that the full shape of the answer can be seen at once. The word at the center of the night has been unreachable, and it is not a mood or a failure of nerve. It is simply what remains when every factor is set down together. Begin with the distance itself. The nearest star lies about 40 trillion kilometers away, more than 250,000 times the distance from the Earth to the Sun. More than 4 years of travel, even for a beam of light, the fastest thing the universe allows. That is the first stone in the wall, and it alone is enormous. But it is only the first. Set beside it the emptiness. The space across that gap is a near-perfect vacuum, light-years across, emptier than any nothing we can make on Earth. No resting place, no halfway harbor, no island in the middle of the sea. To cross to the nearest star is to cross 4 light-years of almost perfect vacancy, alone, with the nearest help unimaginably far behind. Set beside that the speeds. Our fastest machine, at the very peak of its fastest dive, would still need thousands of years to make the crossing. Our fastest sustained travel, the probes already drifting beyond the planets, would need tens of thousands. The fastest a human crew has ever flown would need more than 100,000 years. These are not our weaknesses. They are our greatest strengths, the best we have ever done, and against this distance, they look almost like standing still. Set beside that, the cost of going faster. To reach even a meaningful fraction of the speed of light demands energies near the entire output of a civilization poured into a single ship and paid again to slow it down. And above all of it stands the final ceiling, the speed of light itself, which nothing made of matter can ever reach, and which still leaves the nearest star more than 4 years away, even for light. The wall does not only stand high, it rises faster than any engine can climb, and then it ends in an edge that cannot be crossed at all. And set beside all of that the simplest stone of all. A human life is too short. Even the most hopeful journey, the most generous design, outlasts the one who would make it. The traveler who steps aboard is never the traveler who arrives. To go would be to give up ever knowing whether you got there, to send your distant descendants ahead into a dark you will not live to cross. Lay these side by side, the distance, the emptiness, the slowness, the cost, the ceiling, the shortness of a life, and they are not a list of problems waiting for clever solutions. They are the shape of a single wall, and the nearest star sits on the far side of it. This is the honest meaning of the title. The distance is not merely far. It is far in a way that closes the door, and the more carefully you look, the more firmly it closes. That is why it is worse than you think. Not because the number is large, but because every direction you push against it, the number pushes back harder. We have looked at it as closely as we can tonight, and what we have found, laid out plainly, is a quiet and complete impossibility to the nearest shore of a sea we were never built to cross. A truth this large could be left to sit heavily on the chest, but it does not have to be carried that way, and on a night meant for rest, it should not be. Everything we have said is true. The nearest star is beyond our reach and will remain so. And yet the very same distance that holds us back is also the distance that gives us some of the gentlest gifts we know. The wall that keeps us in is the wall that keeps the sky still, and there is a long peace in seeing it that way. Because the stars are so far, they do not rush or scatter. They hold their places across a human life and 100 human lives, steady points to steer by, the most constant things in all of human experience. Every sailor who ever found a way home by the stars, every traveler who ever took comfort in a familiar light overhead, relied on exactly the distance we have been mourning. The remoteness of the stars is what makes them dependable. A nearer sky would be a restless one, its light swinging and shifting from year to year. The far sky is the calm one, the reliable one, the one that returns each night unchanged. And consider what the distance does not prevent. It does not stop the light of the nearest star from reaching us. Every clear night, the light of Proxima and of thousands of stars far beyond it completes the whole impossible crossing that no ship of ours could ever make, and arrives, quietly, in the back of a watching eye. We cannot go to the stars. But the stars, in a sense, come to us their light does, faithfully, having traveled years and centuries across the dark to be seen. The looking reaches them perfectly well. The distance forbids the journey and permits the gaze. And the gaze, it turns out, is most of what we ever wanted. There is an old feeling that the stars were put there for us to reach, and that not reaching them is a kind of failure. But perhaps that was never the relationship. Perhaps the stars were not given to us to visit, but to look at, to measure, to wonder at, to navigate by, to fall asleep beneath. And in that relationship there is no failure at all, only a long and patient companionship across a distance that asks nothing of us but our attention. We were placed beneath a sky whose farthest lights glow across an impossible distance, and we were given eyes to see them. That they are too far to touch does not lessen the gift of their light. So the distance holds the sky still for us, and sends us its light for free, and asks nothing in return. The nearest star will keep its place tonight and every night, burning low and red and patient, 4¼ light years away, in no hurry, going nowhere we need to follow. It does not need us to reach it. It only offers itself to be seen, and that we can do, lying still in the dark, with the whole impossible distance folded quietly into the light that finds our eyes. We have come to the end of the long walk outward, and there is nothing left to measure. We have followed the distance from the moon to the sun, from the planets to the nearest star, and out past it to the edges of the galaxy and beyond. We have found, again and again, that the gap to the nearest star is worse than it first appears, longer, emptier, slower to cross, more firmly closed than almost anyone imagines. And now, with all of that understood, we can simply set it down and let it become what it has been all along, not a wall to beat against, but a quiet fact to rest beneath. There is a particular peace available in a thing that cannot be reached, because a thing that cannot be reached also cannot be lost. Proxima Centauri will be exactly where it is tonight, long after this night is forgotten, long after everyone now awake has slept and woken and slept again for the last time. It is not waiting for us. It is not calling us. It is simply there, burning slowly at the far side of a distance no one will ever cross, steady and indifferent, and entirely at peace. And there is something restful in keeping company with a thing so far beyond all striving, a thing that needs nothing from us and offers its light anyway. Let the size of it be a comfort rather than a weight. The universe is larger than our reach, and that is not a tragedy. It is only the size of the universe we were born, into an openness so wide that its nearest other light takes 4 years to arrive, glowing faintly in every direction, far more than we could ever cross, and far more than we ever need to. We are small in it, and held by it, and the distances that seem so heavy by daylight can become, in the dark, a kind of wide and quiet stillness, settled on every side by stars too far to ever disturb us. So let the distance hold you tonight, instead of troubling you. Let the nearest star stay where it is, 4¼ light-years away, doing nothing, going nowhere, asking nothing. Its light is already on its way to you, as it has been for years, crossing the whole emptiness we spoke of, arriving without effort at the close of an ordinary night. You do not have to reach it. You never did. You only have to let it shine where it is, and let yourself grow still beneath it. Let your breathing slow now. Let the numbers fade, the trillions of kilometers and the thousands of years, until they are only soft shapes drifting somewhere far behind your eyes. Let the great distance become a gentle one. Let the stars hold their places, far and faithful and calm, while you let go of the day. There is nowhere you need to travel tonight. There is nothing you need to reach. The nearest star is impossibly far away and perfectly at peace, and so, now, can you be. Let your thoughts drift out into the dark and settle. Sleep well, and good night.